So friends, we all know that optics is a branch of physics which gives all the answers related to the light. And there are mainly three parts in optics or three subparts in optics. First is ray optics or the geometrical optics. In this optics, we are considered the phenomenon of light as a ray. And if we consider light is traveling in a medium like a wave, it is branch of physics which describes wave optics. And there is another branch of physics or the optics is the quantum optics. In quantum optics, we are considering the light as made up of small particles which are photons, and this is the quantum optics. So now we will work on ray optics. So there are 3 points on which ray optics is based. These 3 points are: the first is rectilinear propagation of light. It means light will travel from one point to another point in a straight line. It will not travel like this or that. It will travel in a line or in a straight line. And the other consideration is that freedom of place. Each other. It means when light travels from one point to another point, the ray will not interact with each other. They will go parallel to each other. And the third consideration is that reversibility of light. It means, suppose these are 2 medium of 2 different refractive index, and light travels from one here is one point and another point, and after refraction it will go to point C at the point C. So if we reverse the direction of the light ray, it will also travel and it will also follow this path, and this is called as reversibility of light. There was a very big basic point of the ray optics which is known as Fermat's principle. And before the Fermat's principle, there was principle of the shortest path. In the principle of shortest path, suppose here I am at point P and here is the another point Q. So when I want to send a signal from here to here, we all know that from the all other paths, the straight line is the shortest path. It means we will consider the straight line as the shortest path. And from this, the principle of shortest path must come. And after that, we will consider 2 cases. The first, refraction, and the another is the reflection. So now we will see what happens in that. So this is first reflection. Okay. This is the mirror. This is the surface. This. So suppose light is the ray of light is going from point A to point C by the reflection of light. So it will obey the law of reflection, and we all know that law of reflection. Now there are so many ways to go from point A to point C. Here is point B, and the another way is suppose ABC. Now I will draw a mirror image of point C, which is at the equal distance from M dash. It means CM dash is equal to M dash C. So when I draw a line joining to point B and C, it will be line joining to point A and C, and it is a straight line. It means it obeys the law of shortest path. But in the second case, where we take the refraction, it means a normal drawn to the surface, and suppose this is the medium S of refractive index N1, and this is water of refractive index N2. Now, the ray coming out from point A, it will interact with the surface and it will go here. It is due to refraction. There is the another ray which will also go from point A to C. Suppose it is ABC and it is ABC. And now we will draw a straight line joining to these 2 points to check out if the shortest path law is correct or not. So we will draw point joining to A and C. So this is dotted line which shows AC. Now from this we can say that in the both paths ABC and ABC, these 2 paths are longer than the straight line AC. It means here the law of the shortest path is not obeyed. So from these 3 cases, our French mathematician Fermat said that we can replace the law of shortest path by the law of the least time. So what is the principle? And it is known as the principle of the least time or the Fermat principle. So, principle of least time. According to this principle, light will travel from start to end or one point to another point in a path which takes the least amount of time. Suppose it is point P and it is point Q. So there are so many available chances to go from point P to Q. But as we all know that straight line may take the least time. It is not necessary that straight line will take the minimum time. So this is, and these are any optional to available paths. P to Q. Suppose this all thing is happening in same medium of refractive index N. So for the distance dl, it means for this small distance in this medium, how much time will be taken by light? We can say it by dt, and the distance is dl. So from the velocity equation, we can write like this. Okay, and as we all know that what is the refractive index of the medium? So eta is nothing but the velocity of light in the vacuum to the velocity of light in the given medium. So we will put the value in this equation. We will get C by dl into dt. So now the total amount of time taken to travel from point P to Q, what will be it? Yes, it's simply the integration or the continuous summation of dt from P to Q, the limit of P to Q. So now when I will put this value in this equation, I will get 1 upon C, which is constant. It is the velocity of light in the vacuum, and I will write dt. It means dl into n. So what is dl into n? Here in this equation, here is limit P to Q and 1 upon C dl into n. So dl into n, that is nothing but that is delta which is known as optical path length. Okay. So I can put delta in this equation and I will get E is equal to 1.c into delta. As we know, c is the constant and it is velocity of light in the vacuum, we can write this equation, c is proportional to delta. So from this equation, we can say Fermat's principle in this way that light will choose the path from going to one point to another point in a such path that will take the least amount of time, and similarly light will choose that path which has the minimum optical path length. And in another, there are so many paths from going to point P to Q. A parameter, suppose we can say by ds, and the time, smallest time, which is dt. So Fermat principle also says that dt upon ds will equal to 0, because dt is the smallest time and it is limit of delta t tends to 0. It means it is nearly equal to 0, and the ds, it is the difference of path from going to point P to Q, and it is also a smaller quantity. Okay, so smaller quantity by smaller quantity, it is obvious smaller, it will be nearly equal to 0. So now we will see to another case, and first case is for elliptical reflector and the another is the spherical reflector. So let's check it out. So I will draw an elliptical reflector. Okay, it's like elliptical reflector. Here are its two focal points F1 and F2. Suppose I want to send a signal from point F1 to F2 by the law of reflection. So what will I do? I will consider here a horizontal plane mirror, and I will send a signal or send a ray of light here, and it will reflect it back to the point. So it will be the path of this point F2, and I will draw a normal to this surface, and these two triangles are set, and from this consideration we can say that it is I and it is R. This is angle of incidence and it is angle of reflection. So now suppose it is not a parabolic reflector, but it is made out of, it is a elliptical surface which is made out of steel. It will reflect back also a bullet. And now here you are, and here is your enemy. You have only one bullet left in your gun. So what will you do to shoot your enemy? So there is no restriction to check, to prefer angle, because suppose you shoot at this angle. Okay, now here consider a horizontal plane. Here consider a plane, and from this bullet will be reflected, and here we will draw a normal to surface, okay, and here will also I is equal to R. In this case I is equal to R. It means here the least law is followed, and here also the principle of least law is followed. It means the time taken to this two paths are same, though the angles are different. It means if you made and you shoot at any angle, it means you will shoot like this and you will shoot like this. The property of elliptical is R1 plus R2 will be constant. So if the distance are constant, for that we can say that time will be also constant for that. Okay. Now in the another case, which is a spherical reflector, what happens in that? This is a spherical reflector, in which this is object and these are the axial rays coming out from this object. it will reflect it to the surface and it will reflect it back. And so in this case, what happens? In this case, time taken by this ray will be the maximum. It means here the law of least time is not followed, and here time taken is similar for all the cases. It is a stationary time. Stationary time, and here time taken is maximum. And previously we have seen that time taken is least. So all these three cases, it was the case in the time taken was minimum. So from all these three cases, we can see that there is no restriction for light to choose any path from going to one point to another point. It means light may take a maximum time, a minimum time, or it may also take a stationary time. So it is described as the modification of Fermat's principle of least time. And now here is the final derivation of Fermat's principle that light may take maximum minimum of stationary time.
Start.
So friends, here we were with Fermat's principle and its some drawback. So now in next video we will see the application of Fermat's principle in deriving the laws of reflection and the laws of refraction. So if you really like my video, please watch, share and subscribe my channel for the new updates in my channel Physical Learning. Thank you.